You know, what powers the apps on your Android phone or the systems at your bank and even huge parts of the internet? Well, the answer, for almost 30 years now, has often been just one programming language, Java. So today, we're going to break down exactly what makes it so incredibly powerful and, honestly, so enduring.
Okay, so let's start with a really fundamental problem. At their core, computers only get two things, on and off, 1 and 0. So how in the world do we translate our complex human ideas into their super simple binary language? How do we even begin to bridge that massive gap?
Well, this is exactly where we need something like a universal translator, a tool that can take our instructions and just convert them into that simple language machines can actually execute. And for millions of developers around the world, that translator is Java.
I mean, just think about it. On one side, you've got human language. It's full of nuance, context, and sarcasm, right? And on the other, you've got the cold, hard logic of machine code. They're just worlds apart. Trying to write complex software directly in ones and zeros, it would be, well, impossibly tedious and a total nightmare for finding mistakes.
This is really where Java shines. It's what we call a high-level language, which is just a fancy way of saying it's designed to be easy for people like you and me to read and write. We can use English-like commands, and Java takes care of all the messy, low-level details of talking to the hardware. It's that crucial bridge between what we want to do and what the machine actually does.
So how does Java organize all these commands? It uses this really powerful philosophy called object-oriented programming. Now, I know that sounds super technical, but the core idea is actually incredibly intuitive. It's all about modeling the world as we already see it.
Seriously, just think about it for a second. Everything around you is an object. Your phone, a chair, your dog. Each one has its own characteristics and a bunch of things it can do. Java takes that exact same logic and applies it to code, which, just makes designing and managing really complex software so much more intuitive. Let's take a car, for instance. What are its properties? Well, it's got a color, a certain speed, a brand. And what actions can it do? It can start, it can stop, and it can drive. So in Java, we can create a car object that bundles its data, the properties, together with its behaviors, the actions. It's this really neat self-contained little package that perfectly mirrors reality.
And this way of thinking is what leads us to Java's most famous promise. This is the feature that made it a global phenomenon and, I'm not exaggerating, completely changed the game for software development. This is the slogan right here: write once, run anywhere. And this promise was absolutely revolutionary. It meant a developer could write a program just one single time, and it would work on pretty much any computer out there without changing a single line of code.
So, how does Java pull off this magic trick? The secret ingredient is something called the Java Virtual Machine, or JVM for short. The best way to think of it is like a small, standardized computer inside your actual computer. So instead of writing code for Windows or for a Mac, developers just write their code for the JVM. The JVM then acts as that final translator, telling whatever specific device it's on what to do. The whole process is actually beautiful in its simplicity. First, you write your code, just once. Then, the JVM that's living on any given machine, whether it's a Windows PC, a Mac, a Linux server, it takes that exact same code and translates it into the specific machine language that device understands. And the result? Your program just works everywhere. You can imagine, an idea this powerful made Java incredibly popular. It was first created way back in the 1990s, and yet its legacy and its relevance are arguably stronger than ever in today's tech world. So, Java's journey kicked off in the 90s at a company called Sun Microsystems. It was later acquired by the tech giant Oracle, which still guides its development today. And now, we have modern versions like Java 21, which is a long-term support release. That means it's built specifically for the kind of stability and reliability that huge companies trust for their most critical systems. And get this, for nearly 30 years, Java has stayed one of the most popular and widely used programming languages on the entire planet. Just stop and think about how much technology has changed in that time. I mean, that kind of longevity is almost unheard of, and it really speaks volumes about just how solid its design is. So where do you actually find Java today? Oh, it's everywhere. Android, the operating system on most of the world's smartphones, it's built on Java. It runs the back-end systems for major banks, it powers massive cloud computing platforms, and it's the backbone for countless huge business applications. It really is the invisible, reliable engine behind so much of our digital lives.
So you see, Java isn't just some piece of ancient history. It's a living language that has consistently evolved.
For decades, it has really defined what reliability and scalability look like in the world of software. And that leaves us with a pretty fascinating question. After shaping our world for 30 years, what's Java going to build next?